All right. So we're live now, and we'll give folks a few minutes to filter into the room. Thanks for joining us, everyone. All right, so we'll just have another couple minutes. All right, great to see so many people joining. I've got some names I recognize and some names I don't, so it's nice to connect with everyone. Give one more minute and then we'll kick off. All right, I'm going to kick off. So thanks again for those of you who've joined us. So we're connecting together today for our first of a series of 2026 talks as part of the Canadian Reproducibility Network. So personally, if I've not connected with you before, I'm Kelly Colby. I'm a scientist here at the Heart Institute in Ottawa. So I'm calling in from the unceded traditional territories of the Algonquin and Anishinaabe people. And we're really excited, I think, to be kicking off a new year of the network with this session. I think it's bringing us a bit more diversity in talks than we've had. We've been focused a lot on responsible research assessment, which has been great. And that theme will continue to permeate within our session as sort of like a cross-cutter. But the next several talks will have a bit more diversity in topics. So Mamu, when you get a chance, I'll have you put into the link the registration for the subsequent sessions coming up. But for today, we're really fortunate to have Dr. Krista Byers-Heinlein from Concordia University, who's a developmental psychologist, and she's going to be speaking about enhancing reproducibility through big team science. So she'll be specifically talking about the Connect grant, which is a big grant she'll speak more about surely, but funded here in Canada through SSHRC. So over to you, Krista. And at the end, we'll welcome any sort of questions. Folks can raise their hand, but feel free to pop questions in the chat throughout so you remember them for at the end. Go ahead, Krista.
Great, thank you. Can everyone hear me? Yes?
Yeah.
All right, well, thank you so much, Kelly, for having me to speak with you today. And so, yes, I'm going to be talking about a somewhat emerging approach for enhancing reproducibility, which is through big team science. And I am presenting today on behalf of the Connect partnership, which Kelly mentioned, and I'll be talking about more. So first, a little bit about my background, or how did I get here? What am I doing? So as Kelly mentioned, I am a developmental psychologist and a professor at Concordia University. And my lab focuses on understanding bilingualism in infants and toddlers, so language acquisition. So we do things like you can see on this slide. So we invite kids and families into the lab to test their language comprehension. So just, here's a baby participating in a study, and he'll hear some kind of sentence like, look, find the spoon. And we measure, things like how long he looks at the spoon, how quickly he looks at it, his pupil dilation, these kinds of things. Um, and so through this work, between 2014 and 2020, I held the Concordia University Research Chair in Bilingualism. But since 2021, my research chair title has changed to the Chair in Bilingualism and Open Science. And this change represents sort of a new area of advocacy and research that I've been involved in, but it also really parallels the kind of trajectory that I'm going to talk about today that's been happening both in my field and other fields. And I hope that'll make more sense as I tell today's story. So, an overview of the talk today, I will start with talking about crisis, so specifically the reproducibility crisis in psychology, generally speaking, as well as specifically in my field of infant research. Then I'll talk about a solution that uh, has emerged in response to that crisis, which is big team science and specifically the Many Babies Consortium. And finally, I'll talk about the latest evolution of that, which is the Connect partnership and network of networks, which represents new infrastructure for big team science. Okay, so crisis. I know we have people here on this call who are from many different fields, but if you're here as part of the Canadian Reproducibility Network speaker series, I think you're familiar with the reproducibility crisis that we have across many fields. And specifically in psychology, this crisis came to the front in the early 2010s. And so during this period, we had papers that were published, for example, this seminal paper that really showed how p-hacking, so flexibility in how analyses are done and presented, really allows researchers to, have reproducible findings. So really find things that we can't really replicate. One response that came from this was the emergence of a new way of doing research, which was much larger in scale than psychology had seen before. And so the first sort of iteration of this was many labs. Here's an example of a couple of papers. This first paper, where this group of researchers got together and attempted to replicate 13 different effects in the psychology literature. Depending on how you count replication, about 10 of those were successfully replicated. And a second paper, similarly, that only replicated 40 of 100 effects. So, this was a really shocking finding in our field at the time. Is it really the case that only possibly even fewer than half of our effects that in the published literature are replicable? What does this mean for our field? So there are a lot of explanations for this replication, these replication failures in psychology. So some fit under the banner of questionable research practices. So this is things like selective reporting, including file drawer effects, where only significant findings are published, selective analyses or p-hacking type of problems, harking hypotheses after results known. So rather than the typical scientific path of making your hypotheses before you collect and analyze your data, going about it the other way around to make it look like you'd always made these hypotheses and predictions based on the results that you observed. Other problems possibly with lack of specifications of exactly when we would expect to find effects and when we would not expect to find those effects. So seeing a lot of sort of post hoc explanations that certain results maybe should only be expected in this population and not that, although that wasn't necessarily specified in the original research. So, all of these things definitely important in the field of developmental psychology as well, and in infant research. And I can say, as a grad student, in those years leading up to 2010, I was taught to do these things. This was actually part of my research training and considered good research practice at that time. So the file drawer was definitely present. We'd have series of studies in the lab where we just found null results in our infant experiments and they weren't really publishable. P-hacking, I was told, try out different analyses, see if you can find something. We don't want to waste our data, etc. So, I definitely seen all of these things at that time. So, what about infant research? Do we have all of these problems? Well, yes, we certainly have all of these problems in terms of replicability in the infancy world. But not only this, we have even worse potentially problems. So there are so many additional challenges that we see in infant research that we don't necessarily see in research in adult psychology or necessarily in other fields, although certainly every field has its own challenges. So just as an example, we typically have very small samples. Our studies are chronically underpowered to the point that some researchers would engage in sort of these optional stopping practices for data collection, where they would test a certain number of babies, and keep testing and one at a time, and conducting say a t-test to see if that result was finally significant. Now, why do we have small samples? Because, as you can imagine, it's very difficult to recruit and test infants. So in an infant research study, we might specifically be looking, let's say, for 8-month-old infants who are learning French and English. So it is very difficult to find those infants, to get them into the lab, and to actually test them. So a typical sample size would be quite small. And because of that, our research is very slow to do, it's very expensive, and this leads to limited replication of findings, because there's a real stark choice between investing resources into a replication versus a new research study, new research question. We have high attrition rates. So there's many studies that babies don't necessarily want to cooperate in. So depending on the paradigm, we could easily have, let's say, 50% of babies that come into the lab do not actually complete the experimental study, despite very clever ways to try to keep them engaged. Our data is extremely noisy, so infants are highly variable in their behaviors for different reasons. They're hungry, it's nap time, they, have a full diaper for whatever reason. They're in a good mood, they're in a bad mood. This adds a lot of noise to our data. We're contending with developmental change. So, you wouldn't necessarily expect a 8-month-old baby to have the same behavior or cognitive development as a 10-month-old baby. But on top of that, there are also individual differences. So those cognitive achievements at 8 months might not be universal across all babies, for example. There's also challenges with different methodologies across labs. So it's not the case that you sort of order your canonical infant research setup from the, infant research catalog, and here comes your setup, and there it is, standardized like all the labs. No, every lab tends to have a very custom setup based on the specific rooms they have available, the specific computers or monitors or eye trackers or other equipment that they use. So it's all a very custom setup. And we know that infants can be very sensitive to specific conditions, things like lighting matters. Is there a window in the room? Some people hypothesize that the colors of the walls matters. We don't have data on that. But there is this variability across labs. So, okay, infant research, we're in a really tough place. How bad is it? I don't have data on all of these challenges, but as an example of sample size, we have a database in our field of some meta-analyses that have been done on different infant research questions and paradigms. So this is just sort of a figure showing the typical effect size based on some of these analyses, so effect size of different infant paradigms and questions. And within these meta-analyses, we've actually found that the typical sample size is about 20 infants per group, so not a very large sample. And the typical effect size is a coincidence of 0.48. So that means a power of somewhere between 0.53 and 0.66 if we're assuming t-test. So this is not great statistical power. These are big, big problems in our field, and we recognize these problems in our field, and at the same time we realize that labs working alone couldn't necessarily solve these problems, because we're limited in how much each lab could address this. So moving from this crisis to what turned into a start of a solution, or a partial solution to this problem in our field, which was collaboration. And this is the birth of the Many Babies Consortium, which is a big team science network. So the goal of Many Babies is to test questions, research questions that no single lab could answer. And I'm just very proud actually to show our current researcher dashboard. So Many Babies is a very large network at this point. We have 785 contributors across 308 institutions and 55 countries, as you can see, all around the world, definitely more highly concentrated in North America and Europe, but a growing network of researchers in other places as well. And so Many Babies 1, our first project that we did together, was looking at infants' preference for infant-directed speech. So what is infant-directed speech? Well, infant-directed speech is that kind of high-pitched baby talk that adults and caregivers across many, many cultures in the world tend to direct at their infants. And so it has characteristic features. So if you look at the bottom here, you can see sort of the pitch contours of an infant-directed sentence. So this is something like, can you say ah? Say ah. Hey, you. Say hi, hi. That's typical infant-directed speech versus something like adult-directed speech is more monotone with less extreme pitch contours. So in this example, I had a little bit and the doctor gave me Bendectin for it. So infant-directed speech is a pretty non-controversial topic in our field. So we're pretty sure that this is something that is good for babies learning and babies like. And so we decided for our first collaborative project, trying to work all together to test infants' preference for infant-directed speech. The general approach that you would use in infant research to look at this would be with a looking time approach. So this is an indirect measure of infant attention. So generally, we would try to measure infants' looking time or interest when we play them clips of infant-directed speech versus when we play them clips of adult-directed speech. And of course, when I say that, it sounds really simple, but indeed there's many types of methodologies and variations that you could use to test this. So, for example, there are different paradigms that you can use even within looking time. So you can have an automatic eye tracker that's going to automatically categorize infants' eye gaze. You can record on a digital recorder or a video camera and have research assistant offline measure how much an infant is looking or not looking. There's paradigms where an infant looks straight ahead, others where an infant turns their head towards a source of sound. There's many questions about what type of stimuli you want to use. So are you going to use recordings from actual parents with actual babies? Are you going to have a voice actor come in and produce infant-directed speech? How many different trials are you going to use? What length of the trials should there be? What should the ages of the infants be? So there are many variations you could use within this general paradigm. There was one previous meta-analysis that was used, that was done to look at infant-directed speech preferences across the literature. And so this is collapsing across many, many variations in all of those factors that I mentioned. And you can see the variability in effect size. But overall, the literature does confirm that there is a preference for infant-directed speech over adult-directed speech. The mean effect size is about 0.65 with no significant age effect. If anything, it's possibly a stronger preference for infant-directed speech amongst younger babies than older babies. So that was the general project that we set out to do. And I want to give you a little bit of a timeline of what it looked like to sort of start and conceive of that project and how we got to the end of that project. So the idea for Many Babies actually arose around 2015 with a series of conversations at conferences, sort of saying, oh, what about this replicability crisis? What about infancy? Is this affecting us? Yes, it is. What can we do about it? A series of emails and a growing email chain, which eventually led to a listserv. This was formalized towards the end of 2015 and towards 2016 when we decided, okay, we're going to do this joint study together. There's a whole process to select this first topic for studies. There are many ideas of things that we could study. We selected infant-directed speech. There was a very prolonged period of designing the study protocol, creating the stimuli, and this was a very collaborative process. So this was not the case of one researcher being in charge and saying, this is how we're going to do it, but this was a case of the whole community coming together to co-design and co-create this study. And there are many controversial issues. So for example, you have to choose a language that the stimuli are going to be in, and that language is going to be the native language for some children, the one that they're hearing at home, and an unfamiliar language for other children. So what is the best choice of stimulus language, for example? So this design phase took quite a long time, as you can see. We had some piloting, and then we submitted a registered report in 2017. This was a really important part of our process, having this registered report. The idea being that this protects us from this very large output of effort and data collection. Should the results be confusing, difficult to interpret, we'll still be able to publish it. Middle of 2017, labs officially signed up to participate, and data collection occurred over approximately a year. And then we have quite a long period here, you can see, for data analyses, presenting at conferences, manuscript writing, and the final publication, which was in 2020. I will say the data analysis ended up being much more complicated than we expected, not because we didn't know what type of analysis we wanted to do, but despite providing data templates and extensive instructions, the data that we got from all the various labs didn't necessarily meet the data specifications in many different ways. So there was tons and tons of data cleaning that had to occur before we could even analyze the data. So this whole process took really 5 years in total, and about 3 years from that stage 1 registered report, when we had a finalized, pretty much finalized protocol, to publication. So the timeline of this project was really quite long, and this is a completely collaborative approach along the way. So anyone could contribute to writing the registered report, helping with the data analyses, etc. All right, if you're interested in what the actual results were from this study, well, here they are. So we actually divided it between infants who were exposed to North American English, which was actually our stimulus language. So these sentences would be familiar to them, and those learning another language. In total, we had 69 labs participate with 2,329 babies. There are 149 authors on this study. And we found, yes, we did replicate the significant preference for infant-directed speech. That was a big relief for us. We interestingly found an age effect such that older babies actually had a stronger preference for infant-directed speech. So if anything, this was opposite the patterns that we'd seen in the meta-analyses. And there's also this language background effect. So babies learning North American English showed a larger effect than babies learning other languages, so a stronger preference for infant-directed speech. I'll just show you the data as well in another format, so you can see this sort of lab by lab data. And here it's actually pulled apart by different methodological approaches. So we actually wanted everyone to be able to really implement the exact same procedure. And we found out in the planning stages that this was impossible because there's no one setup that every lab had access to. So there were actually 3 main setups that were possible. HPP is head-turn preference procedure, where infants again turn their head to show their attention. Eye tracking, automatic eye tracking, and central fixation. This is when a research assistant goes back through video recordings afterwards to see what the infant has done. So something else I'll mention is that our overall effect size in a study was smaller, quite a bit smaller than the meta-analytic estimates. We did find this effective method. So this head turn method had the largest effect size, which was very interesting and surprising, and something that we could not really have found out without this large scale collaboration. We do not know that this is a causal relationship because labs were not randomly assigned to these different methodological conditions. They were able to choose their methodology. And just something to point out is this huge variability across labs. So here we're not taking into account this age effect, but nonetheless, we can see that these effect size estimates are all over the place. These are 95% confidence intervals, and you can see that for many, many labs, those are crossing that 0 point. So really showing that these small scale studies, single lab studies, really might not be robust enough to reliably show these effects that we have in our field, even though this preference for infant-directed speech was specifically chosen because we thought it would be one of the most robust effects that we could test. So Turning to many babies a little bit more generally, and as we worked through this process, we developed a set of principles that really underlie everything that we do. So really our many babies philosophy. So one of those is transparency. So everything about our projects from design to publication are as transparent as possible. We use a collective governance model where decisions are made jointly and transparently, again, when possible and feasible. This definitely increases our timeline compared to if there was sort of a central individual or a few people making decisions. We value inclusivity and diversity, both in terms of the contributors to the projects, but also the populations we study in research questions. We're committed to best practices and high ethical standards, and we encourage a respectful community through a code of conduct that all of our collaborators sign. We also formalized the aims of our different projects, and I will show you how our projects have expanded far beyond that original Many Babies One project, but we are interested in validity, so assessing the replicability, generalizability, and robustness of our key findings in infancy. So first of all, whether or not an effect is present, but also understanding the effect size as well as moderators. Importantly, we don't necessarily do direct replications of existing studies in the field. We use consensus paradigms. So this is everybody coming together to really design the paradigm that we together think will be the best test of our research question. We're also interested in theory, understanding infant development across a wide range of ages and experiences, as well as methods to understand sources of variability across labs and to establish best practices. So as I mentioned, Many Babies One was our first empirical projects. We now have 3 completed empirical projects. You can certainly ask me if you're interested in what specifically they were testing, but Many Babies 3 and 4 are now complete. We have 2 studies that are still in the data collection and redesign. So Many Babies 2, which is a project that has certainly taken a long time. These projects are named in order. Many Babies 5 is just launching. And we have 2 new Many Babies projects that are in the initial design phase, Many Babies 6 and 7. We also have methodological projects as well that are aimed to improve reproducibility. So Many Babies Demographics, which is now published, creating a joint consensus demographic form to collect information about infants' backgrounds around the world, tackling thorny issues like, how do you assess race or ethnicity or other types of background information across different contexts where there are different sort of ways of thinking and ways of being and even legal requirements. For example, how do you assess infants' age when in fact across cultures, they're actually not every culture counts age from the day of an infant's birth, for example. Many Babies at Home, that looks at remote data collection for infants, and Many Babies Webcams, which looking at a webcam variant of that. There are several ways that Many Babies has enhanced reproducibility. I'll talk about very few of our innovations. So one has been walkthrough videos. So one thing that I mentioned was that there's a huge variability between labs in the specific setups, how babies are tested. And walkthrough videos are what they sound like. So when a lab participates in a Many Baby study and contributes data, they do a walkthrough video of either a real infant or a doll or a stand-in of the whole experience that a baby has from the moment that they sort of arrive by transportation to a lab through testing to really see what that looks like across labs. And you can see some interesting differences here already. So here in this lab in Zurich, infants are seated on sort of in a car seat, in a reclining chair with a parent seated behind them. In some other labs, so you can see in these 2 labs, an infant is sitting on their parent's lap. Here we have a video camera that's poking through a hole with these small screens and speakers. Here we have an automatic eye tracking monitor, for example. So we're still looking at best ways to sort of analyze and compare these videos across labs. Some other direct benefits to reproducibility include increased sample size. So we're talking about thousands of infants participating in a study compared to maybe a couple dozen in typical single lab studies. Increased sample and researcher diversity to better understand infants across the world. fully open and reproducible methods and materials. So all of the stimuli are available, all the instructions, even the scripts to run the studies are all available online. Open data and code for computational reproducibility, etc. But beyond these sort of direct benefits to reproducibility, which I think are more easy to think of, uh, big team science, like many babies, offers a lot of indirect benefits to reproducibility. So, first of all, participants in these projects learn directly about open and reproducible research. So they see the process of a pre-registration, of a registered report, of how we share materials and code. And so this is a great learning experience. And I think it also leads to cultural change. So everybody in the field participating in this joint experience, it really normalizes these reproducible research behaviors. We did a brief exit survey from Many Babies One, just looking at labs experience. We had 65 labs who responded, and 53% of them indicated that participating in this project changed their lab practice. So in terms of them adopting practices such as open data, using the open science framework, pre-registration, open materials, using online video repositories, power analyses, and registered reports. So these are really interesting preliminary results, and we'd really like to expand on these to get more data on this. And I can say for myself personally, Many Babies was my own introduction to open science and reproducible research. And this was the first time that I participated in pre-registration and sharing data and code, and really motivated me to transform my own lab's practice to a fully open and reproducible workflow. So Many Babies, meanwhile, is not the only big team science network. So at the same time as we were engaged in Many Babies One and the other Many Babies projects, other networks emerged. So these are fields facing similar challenges to infant research, interested in similar solutions. So we have Many Primates in 2017, the Psychological Science Accelerator, which studies mostly adult psychology, most oftentimes online studies with adults around the world. Many dogs looking at canine cognition, many birds looking at avian cognition, as well as many fishes in 2021. And this is only a small sample of these networks. So we've heard of many other networks, from many goats to many classrooms to many EEGs. So there's a big interest in this type of big team science within different fields in the social and behavioral sciences, especially. And as we were all sort of starting to do this type of research, of course, we all noticed that doing big team science is hard. It's not easy to do these projects. And there's many challenges that come from here. And here's a few that we identified at a hackathon that we had at a big team science conference. So there are definite challenges to processes and workflows. So how do we make sure that methodologies are consistent across teams? Even if we create a lot of manuals and a lot of instructions, methodological variability, unwanted methodological variability still creeps in. Other examples, different levels of contribution. So, how do we track these levels of contribution? How do they relate to linear authorship orders? What happens when contributors lose interest? How can we attract contributors when the outcomes of the study are unknown? There are challenges for infrastructure and tools. How do we manage these large volumes of data? How do we track different documents and collaborators? There's different levels of technical expertise. So in Many Babies, we do our analyses in R, for example, and using GitHub, but not all of our collaborators have expertise in these methods. So how can they contribute, or how could they learn these tools and methods? Are there other easier to use tools that we should think of using? Even things like scheduling with time zones around the world. It's nearly impossible to have a meeting that everyone can attend. How can we onboard new collaborators? Funding mechanisms are certainly a huge challenge. So funding that can be distributed to these international teams. So most funding is typically country-based. So how can we distribute funding? And our research design model is such that it's a collaborative process of determining the final research design. We need funding even to support those early parts of the process, but typically funders want to know what is your actual research design before awarding funding. There's also issues of EDI, equity, diversity, inclusivity, so differences across disciplines, which can be very challenging. How can we deal with interpersonal issues when this is across multiple institutions? There's some concerns about lack of diversity in leadership, cultural differences, accessibility, etc. All right, so many networks were encountering these issues, and we realized that, yes, these issues are similar across these networks, but there have been limited knowledge sharing. With each team reinventing the infrastructure, reinventing ways of working, lack of a systematic understanding about what makes big team science collaboration work and work more smoothly. Training opportunities might possibly have been leveraged across networks. If everybody has a need to understand how to do certain activities, but training is only being offered by one network, how could other networks take advantage? We're focusing on similar challenges, but reinventing the wheel every time and really sharing knowledge only informally when a new network would reach out to a more experienced network for advice. So this leads us to the final and current phase of this journey, which is infrastructure. So the Connect partnership, as Kelly mentioned, is a SSHRC-funded partnership grant, $2.5 million 7-year grant, building a network of networks in the big team sciences. So the partnership brings together these big team science networks here, as well as others that we're currently onboarding, together with other interested organizations, including the Canadian Reproducibility Network, but other organizations you might have heard of, such as the Centre for Open Science and FORT, and others you might have heard less of. So ABREER, which looks at increasing EDI representation, and Children Helping Science, which is a platform that is specifically a partner of many babies. I'm one of the co-directors of Connect, together with Kylie Hamlin and Melanie Stotterstrom. We happen to be the co-directors because we are Canadian and thus can be co-investigators of this grant. But certainly we're very grateful to SSHRC for supporting this and providing some consistent funding in a way that's really been a struggle for all of our networks over the past number of years. So Connect has 3 core initiatives. So first, to better understand processes and workflows in big team science, as I alluded to in some of those challenges. This includes gathering sort of qualitative information about how these networks are actually operating, what's working, what's not, and develop and refining more standardized evaluation tools for our projects. Number 2, improving efficiency and effectiveness in big team science. So designing solutions for our most pressing needs, whether this is templates, policies, workflows, tools, training, and infrastructure. And finally, promoting equity, diversity, and inclusion in all aspects of big team science. One of our current initiatives is a special issue on EDI in big team and international scientific collaborations. To do this work, we're using 2 methodologies. So one is a meta-scientific approach, where we're actually creating and adopting different existing tools to evaluate big team science in a more traditional way. So using questionnaires, qualitative, more formal qualitative research methods. And our other approach is a participatory action research approach. So the idea here is we want to understand big team science as researcher participants of big team science. So what that looks like is literally doing the meta science as we participate in the big team science. So launching projects both within and across networks, discovering different insights through town halls, hackathons, discussion panels, refining our processes as we go for subsequent projects, and improving and implementing new ideas, all while translating and mobilizing our knowledge. I should also mention 2 important hubs as part of this partnership. So one is the Big Team Science, or BITS Lab. So this is a group that has quarterly meetings where different partners share progress in studies, research improvement initiatives, and consider potential solutions together. And formulate plans for developing tools. The second is Many Manys. Many Manys is an exciting cross-network initiative that has joined together these different networks, looking at different aspects of behavior across different species and taxa, as well as other interested researchers who may not be part of these networks, and looking at this from a comparative cognition perspective. So Many Manys is finalizing a research design that will look at reversal learning across these different species and taxa, and trying to compare this to each other. And the idea here of Many Manys is that this is really an even larger challenge than working within a single field, because we have now multiple fields needing to work together. So some final conclusions before we open it up to questions. So starting with crisis, I don't think the crisis is over because open and reproducible research practices are far from universal in the social sciences. They're far from universal in infant research and far from universal in psychology. So there is certainly a huge way to come. And I think, preaching to the choir when I say that there's a lot of work to still be done. But in terms of collaboration, we've developed this new model of working together, of grassroots, open, big team science, which has both direct and indirect benefits to reproducibility. And we're at this next stage of infrastructure where we're working more formally to improve big team science, which I think can have far-reaching impacts on reproducibility. If you're interested in getting involved in this, we have our annual Big Team Science conference every October, so you can go to our URL, bigteamscienceconference.github.io. It has the program from last year's conference, and you can sign up to the mailing list. We welcome you to join any of our Connect working groups working on meta-science, tools and infrastructure, or EDI, and some of you on this call are actually part of those working groups. And you can learn more or connect to us at Connect by going to our website, connect-btss.github.io, or emailing our central administrative listserv for questions or more information. So with that, I will say thank you, and I will take your questions.
Wonderful. Thank you so much, Krista. Really great talk and context for the work that you're doing in big team science more broadly. So we have lots of time for questions, so I'll open the floor. I have some questions of my own, but if anyone is wanting to jump the bit and ask a question, please raise your hand. And if you're willing and able to, if you want to turn your camera on, it's always a little bit nicer for the speaker to know who they're speaking to. Right. I can start if that helps people. Oh, we've got Dom there. Go ahead.
Always happy to volunteer to ask questions. Hi, Krista. Thanks very much for a fascinating talk. It's great to hear about all this excellent work that your group and other groups in the many and big team science areas are doing. It's interesting to hear you speak about funding, obviously, given, I guess, the hat I wear most often at a funding agency. Great to hear that SSHRC is funding this big project of yours, the Connect project. I was curious, though, to maybe hear you expand a bit more on the challenges of funding these projects across these different countries, and exactly how you go about doing that currently and in past initiatives. Is it that people co-develop a proposal for a given project, and then that is sent around, and then it's submitted to national funding agencies in the different countries? Or is it that some people are able to get bigger grants and then kind of share that with others? Or is it that sometimes people simply don't have the money and just cobble it or try to do this off the side of their desk to participate in these initiatives?
Yeah, thank you for giving me the opportunity to talk more about funding, Dom, because it's a huge topic, and it is,
I can imagine,
I would say, one of the central concerns that these networks have. So I would say that the vast majority of the projects are unfunded. So as you say, these are projects people are doing out of the goodness of their heart, off the sides of their desk, scraping together a few funds here and there. It's volunteer labor, and that's really how most of it's happening, which really exacerbates EDI issues because, of course, it is the better funded labs that have a little extra money around that are more able to do this in this way. For projects that have received funding, so there have been a few instances of sort of the leads of a project submitting a designed project to a national funding agency, and then those funds would go to those project leads. So, for example, there's a group, Many Numbers, that got a large American grant, can't remember if it's NIH or NSF, but looking at cognitive development, numerical cognition in infants. There's some Many Babies projects that have received a little, like some foundation support or institutional support. So there was like a grant from Princeton University that had some that an internal grant that they were able to get. There's a little bit of European funding sometimes, but that often specifically goes to funding European labs. Even when we get funding, it's extremely difficult to distribute it. So we're even having that problem right now. Maybe, Dom, you can help us solve this. So within this connection grant, we had a plan to distribute some funds to our other partners around the world. Those institutions will not accept those funds without overhead. SSHRC will not allow money to be spent on overhead. So we are at just an impossible place where we're wanting to support our partners and not finding ways within the system to support the partners. And we've seen that in other cases as well, that it's very difficult and time consuming. It's really no one's job to take that time to administrate it. Even if we could send the funds, it takes so much time to coordinate between the different institutions when, colleagues, there's colleagues where $1,000 could make all the difference between them being able to run a whole project and not being able to run it, and we cannot get those funds to them. So I will say that like funding is one of the biggest preoccupations, and we're looking for ways to work around that.
Yeah, I'm not surprised to hear that. We can talk about it some more, perhaps in a different context, but it just makes me think that, I mean, it is an issue that we face in all contexts. And I think the way that funding agencies have gotten around it, at least in Canada, is that through these joint initiatives where they essentially sign MOUs with other funding agencies to support projects, but then the money kind of stays in the respective countries. So it's difficult to have a very broadly distributed project in many different countries, but it's one avenue.
So we have looked at these, and so there may be, let's say a Canada-Japan initiative, but really there's one or two labs in Japan and a handful of labs in Canada, but it's just so globally distributed that again, it does contribute to the sort of rich get richer aspect, because it's really the more well-funded countries that have these programs available. But
what I could offer is to get you to come over at the agencies, present what you've just shown us, and perhaps start some conversation to get people thinking about how we can approach that.
I would be thrilled to do that, and that is well within the sort of scope of Connect as well. This is the kind of thing that we really want to do, because these are the things that are really keeping big team science from really reaching its potential. So it would be great we can talk offline about that.
Yeah,
thanks, Tom.
Yeah, great. Thanks both. Shinichi.
Hello, Krista. Thank you very much for such an interesting talk. So you probably get asked a lot about this question about recognition. You touched on it. So we have done, I'm an ecologist, evolutionary biologist. We've done lots of those, cohorts of 20 up to nearly 400. And the people would ask, like, what are those, middle authors and all these people are getting? And, some leading person, like, how this kind of, for the PhD student, how that's gonna work and all those things you probably thought about. And if you can share some thoughts on this, would be great.
Yeah, that was my question as well, Shinichi. I've heard, and I quote, that people have said that big team science is built on the backs of grad student slates. And, the first time I heard it, I found it quite jarring, but, understanding that perspective and their role and what they get out of it is I think a challenge of big team science. But Krista, what are your thoughts?
I mean, I think this is something really important to think about. So on the one hand, it's a systemic issue, which, groups like Dora are working towards. How can we recognize these very important contributions? But we live in a reality where, first authorship is what's valued and middle authorship may be less valued. I can speak about, what the students that I've known and the students in my lab who have gotten out of it. So first of all, I would never recommend to a student that this is the only type of research that they do. So when my graduate students participate, this is an add-on to other work that they're already doing. And I would really want them to control the amount of time that they're contributing to that versus other projects that they're involved with. I've had undergraduates involved in this, and this has been a huge boom for them because middle authorship as an undergraduate is great. And they get a really amazing experience far beyond what a typical undergraduate thesis does. But I would say graduate students and postdocs get a lot of benefits as well. So there's a big networking aspect where they're interacting directly with researchers they would never meet, and they can get as deeply involved as they want. So we run a very non-hierarchical organization, and so if a student at any level is really keen to take on a task, they can just do that. If they develop those data analysis skills, they can contribute directly to the code base of analysis. They can help with the design. So they do experience the network and these high-level scientific discussions, often that involve multiple PIs that they really would not be privy to in other situations. So, I think that my students anyway, and the ones I've known, have really enjoyed their experience and have learned a lot. But I would say that it's not really a standalone kind of research career that works in the current system. So you need to have something else beyond your participation in big team science.
Or we need to just change the whole system, right? We'll do both.
That's
exactly. No, it's difficult because I wrestle with this as well, right? In terms of how people are rewarded. I don't know if there are other questions or comments, but I think kind of related to Shinichi's question, one of the things I was also wondering about, and others on the call, feel free to chime in too. Is there any like awards or recognitions in this country for big team science in terms of thinking about like training the next generation in Canada and promoting big team science, like even at a national level? We hear a lot, I feel, about like cross-sectoral work or cross-disciplinary work, and I think very much big team science sort of has those sort of core values. Does anyone know, like, is this acknowledged or rewarded or on the types of agendas of funders at all?
That's great. I do not know of any in Canada. There's one award that has been given to big team science collaborations, which is from the Society for Improvement of Psychological Science, which itself is quite a small organization, but shares those values. But and there have been some awards from the Einstein Foundation as well.
That's what I was thinking of as well. We don't have an equivalent though, I don't think.
Yeah, I absolutely, I agree that these, it really is about changing incentive structures, and awards are a great way to do that. So that's really interesting, Kelly. Yeah.
Eli?
Yeah, just coming in on that because I work on President Awards, in fact, with Krista sometimes. And the short answer is no. There's nothing that I'm aware of, but I will be looking into it, and I can get back to you. But as far as these major recognitions, they really go to smaller teams or individuals, unfortunately.
Interesting. And even Krista, we had it just briefly with the one paper I was involved with your team, but I've certainly had it in other teams as well. Even like the journal submission process, how to recognize like these massive lists of authors. Shinichi, you're laughing. You've obviously been in this situation where there's oftentimes it's just like a group name, so there's no actual person named, or they name a few people and then hide everyone else. And I've been on like the good and bad side of these decisions in the past in terms of how it reflects as scientists in the current system. But this is a major challenge, right? So in medicine, we have sort of ICMJ criteria for authorship. in other disciplines, I think it's a bit grayer. Even the application of ICMJE is quite gray. Have you encountered that, Krista, beyond our
Yeah.
experience together?
Yeah, so I mean, you've raised multiple issues. So, there's first, what counts towards authorship, and typically each big team science consortium will have its own guidelines, and Many Babies has guidelines for
Yeah.
what warrants authorship, and those are very specific. But beyond that, there's of course the technical. Well, there's also a technical problem. So. In most portals, it is not possible to upload a spreadsheet of authors. You have to add them one at a time and search for them in the system and add the email and the title and the address. So this can take dozens of hours to do. So that's a technical problem. But then there's also the policy problem, which you also point out, that there can be just limits on number of authors. So we recently submitted a paper to a journal on a special issue about big team science that had a limited number of authors. It was like 6. And it's not that we had 100 people on this paper, but I think we had 8. And, we reached out for them for an exception. And, and so we had to move to a consortium authorship model. So in fact, the authors were no longer named, which was unfortunate because there were early career researchers who sort of lost out on having their name listed. So there are multiple issues related to authorship. And yeah, thanks for bringing that up, Kelly.
Yeah, we've certainly encountered them. I see in the chat, Dom, I don't know if you want to speak towards this, the SSHRC Impact Award. 50 to 100K.
Sorry, I'm listening and doing the dishes at the same time here. I mean, they're probably not that I know of. There are no awards that are specifically dedicated to big team science, but I think that something that is worthwhile is looking at other types of awards that might celebrate big team science and raise the profile of big team science. So the SSHRC Impact Awards is one potential avenue for that. It comes with money also, which is nice and potentially could be used in a flexible way. I'm not super familiar with the exact constraints around that money and how it can be used, but if you look at that webpage, there's information, and I believe there are webinars as well. And I've been to some in the context of other grants, and the people, like the program officers, are usually fantastic at answering questions and providing information that might not be contained in the online package.
Great.
So I'd encourage you to look at it and apply if you think it's suitable, or circulate it to other people. And I think just more generally as well, it's celebrating research, I guess, across a range of different fields. It obviously needs to be related to SSH somewhat, but that would include meta research and other work on reproducibility. So might be of interest to many people on this call.
For sure. All right. Well, we're drawing to a close, so I don't see other questions. So I'll sort of close us off with, firstly, a big thank you to you, Krista, for your time and preparation for a really great talk today. We have it recorded, so folks who haven't been able to join us will be able to check that out, and folks can share in their network. I will also say Mamoon has put into the chat the link to the next session. So David Mower, you're up next in February. And looking forward to your session. I don't even remember what you're speaking on. Your responsible research assessment of faculty and staff. So it should be a good one. I'll also note that we sent around an email following our town hall in December, and folks were encouraged we gave some updates and encouraged folks to sign up for various working groups. We're going to send a reminder for folks to do that. And then by the end of the month, get back to folks in terms of setting up initial meetings for those working groups and what their objectives would be. So those objectives obviously will be sort of co-developed and decided amongst the group. But what I don't want is a convening of people with no purpose. So I would like them to collectively decide sort of a short-term and long-term goals of the folks who are gathered together. So you'll be hearing from Mamoon and I about that shortly. If you have any questions or want to connect, please don't hesitate. Otherwise, have a great day, everyone. And thanks again, Krista. Take care.